Hello future engineers, this is part 5 of plane trusses, and these 5 problems are the most challenging problems that you will experience. So find the force in member JQ for the Baltimore truss where all angles are 30 degrees, 60 degrees, 90 degrees, or 120 degrees. So this is member JQ. Now, the technique is first we solve for HQ by isolating joint 8 summation forces vertical. So obviously force in HQ is equal to 1000. HQ minus 100, sorry. HQ minus 100 equals 0, so HQ is 100. So FHQ is 100 kilonewtons tension. Then we isolate joint Q so that this angle is 30, this is also 30. Then we rotate the axis so that we can solve for the force in JQ. So that's the trick in this problem here. So this is HQ, which is 100. Then this is QX and this is GQ, remember. So I will not name them because they are not involved after we rotate the axis. And this is member JQ, FJQ. So that's 30. This is also 30. Then we draw a line through Q perpendicular to these two members. And we will set RU equals 0. This is also 30, but these 30, 30 are enough. So R sub U equals 0. So FJQ is directed, its component is directed along the U axis. So it is FJQ sine of 60 equals FJQ sine of 60. Then the component of 100 in the direction of U is plus 100 sine of 30. So from there, we can now solve FJQ, negative 100 sine 30 to the left, then divide by sine 60. So FJQ is negative and it is 57.74 because 74 kilonewtons. Because it is negative, so it is compression. A vaulted roof truss is loaded as shown. Determine the force in members FG, GH, and HJ. State if the force is tension or compression. So here's the given figure. If you look at the loadings, they are equally spaced and symmetrical. Therefore, the total load is 2.4 plus 2.4 plus 2.4, 2.4, 2.4. 2.4 times 5 plus 1.2 plus 1.2. So that's 14.4 kilonewtons. Therefore, or 2.4 times 3, 6 times 2.4 kilonewtons, so divided by 2, so 3 times 2.4. So the vertical reaction at A and K will be 7.2. The horizontal reaction at A is 0 because there's no inclined load. So 7.2, that's also 7.2. Where 7.2 is you add all these loadings divided by 2. So we don't need to sum up moments at A or at K to solve these reactions. Then we consider this sectioning through HJ, GH, and FG. And let's consider all forces to the right, the simpler and lesser forces involved. And let's draw a bigger free body diagram here. So we have horizontal distance KJ 1.8 in the given figure, 1.8. Reaction at K vertical 7.2 kilonewtons. Then the loadings, then vertical distance between K and H is 0.9 given here, that's 0.9. The total vertical distance from K to F is 2.4. But because this is a straight line equally spaced at 1.6, 1.6, so the vertical distance will also be equally spaced. So meaning Ki is 2.4 over 3. So that's why we have 0.8 here. Distance between I and G vertically also is 0.8 because the distance between G and F vertically is also 0.8. So that makes it 2.4 meters. Now for other, we need the angles also. So this is 1.6, 1.6 horizontally given in the figure. So this is FFG, this is FGH. The angle that FFG makes with the horizontal, let's call it theta FG. And this is GH, the angle it makes with horizontal is theta GH. And this is HJ. So all the required member forces are in this free body diagram. And the angle it makes with the horizontal, let's call it theta HJ with horizontal, which is the same as this. So I'll just put it here. Then the intersection between GH and HJ is at H. Call that point H to solve for FFG later. So this horizontal distance between G and H, if you look at the figure here, the horizontal distance between G and H is 1.8 times to 3.6 minus 3.2, 1.6 times 2, so that's 0.4. Again, that's 3.6 minus 3.2, so 0.4. The vertical distance between G and H is 1.6, 0.8 times 2, 1.6 minus 0.9, so 0.7. That's 0.7. Then theta FG is 26.565 degrees. Why? Because here it is arctan of 0.8. Remember, vertical distance between FG is 0.8 divided by 1.6. So that's 26.565 degrees. Theta GH is arctan of 0.7 over 0.4. So 60.255 degrees. While theta HJ is arctan of 0.9 over 3.6. Or arctan of 0.45 half over 1.8. It's the same. So theta HJ using your calculator there is 14.036 degrees. There's no need to show the calculations here. I already mentioned. Then for the horizontal distance between G and J, it is 3.2. 1.6 times 2 minus 1.8. So 3.2 minus 1.8 is 1.4 as shown. The vertical distance between G and J is 1.6 minus 0.45, where 0.45 is 0.9 divided by 2. Half of 0.9. So 1.6 minus 0.45 is 1.15. So this is 1.15. So we now set moment at H0 to solve for FFG. Counterclockwise positive. The horizontal component of FFG is counterclockwise. FFG cosine of 26.565. Then the moment arm is 0.7. The vertical distance or the vertical component of FFG is upward. And it is also counterclockwise about H. So plus FFG sine of 26.565, the vertical component, times moment arm 0.4. So FFG sine of 26.565 degrees times moment arm 0.4, this 0.4 here. Then plus 7.2 times 3.6. Then minus 2.4 times 0.4. Clockwise, so minus. Minus 2.4 times 1.6 plus 0.4 is 2. 2.4 times 2. Moment arm is 1.6 plus 0.4, so 2. Then minus 1.2 times 3.6. So using your calculator there, this last three terms become positive when transposed to the left. So 2.4 times 0.4 plus 2.4 times 2 plus 1.2 times 3.6 minus 7.2 times 3.6 divided by quantity 0.7 cosine 26.565 plus 0.4 sine 26.565. You have your calculator there. It is your problem if you cannot calculate this. There's only FFG left. So FFG is negative 19.68 kilonewtons. So that means FFG is 19.68 kilonewtons compression. Next, to solve for GH, FFG and FHJ pass through K. So we set moment K is 0 to solve for FGH. Counterclockwise positive again. So 7.2 and 1.2 will not be involved. FHJ and FFG will not be involved because they pass through K. So we have fewer forces. The horizontal component of FGH is counterclockwise. Remember, counterclockwise positive. It is FGH. It is FGH cosine of theta GH. FGH cosine is 60.255 degrees. The moment arm is 1.6. 0.8 plus 0.8 for the horizontal component of FGH. For the vertical component, it is also counterclockwise. So plus FGH sine of 60.255 degrees. The moment arm is 3.2. 1.6 plus 1.6, 3.2. So then plus this 2.4 here times 3.2 also. Then lastly plus 2.4 times 1.6. So we only have FGH as unknown in this equation. So it's again negative after we transpose this constant to the left. Using your calculator, FGH is equal to negative 3.225 kilonewtons. So FGH is 3.225 kilonewtons compression. And finally, for FHJ, we sum up moment about G equals 0 or mg equals 0. This time, clockwise positive. So the horizontal component of FHJ is clockwise. So it is FHJ cosine of 14.036. The moment arm is 1.15. This 1.15 here. Then the vertical component is upward, but it is counterclockwise about G. So minus FHJ sine of 14.036. The moment arm is 1.4. This 1.4 here. Then these are all FHJ clockwise positive. So plus 2.4 plus 2.4 times 1.6. Then plus 1.2 times 3.2. Moment arm of 1.2 is 3.2. Then don't forget minus 7.2 times 3.2. So it's only FHJ that is left in this equation here. So using your calculator, FHJ is positive 19.79 kilonewtons. So therefore it is tension. So I slowly present the solution so that you can follow. If it is still fast, you have to pause the video and analyze and look at the equations I established. Determine the force in member AC of the plane compound truss loaded and supported as shown below. Inside and outside triangles are equilateral. Solve in two ways. So this is the beginning of the challenging problems, very challenging problems. Actually, these problems there are three, 24, 20, 23, 24, 25. These are star problems from the book by Timoshenko. So obviously, because F is the load is at the center, so horizontal reaction at A0, then the vertical reactions would be half of Q. So 0 horizontal reaction at A, then Q over 2, at C also Q over 2. So this is the first solution. We have to consider joint D first, then let's express forces of the members, other members in terms of FAD. Then once we proceed to D, E, F, until such time that we can solve for the value of FAD. Then after we solve for FAD, because this is equilateral, that's 15 degrees, so meaning this is 45 degrees, then we isolate joint A because there are only two unknown forces left, FAB and FAC, wherein FAC is the required. So what is important is we must solve FAD first. We must know the value of the force of FAD because we cannot isolate joint A. We cannot solve the force in FAC directly because in each joint here there are three member forces and there are only two equations of equilibrium. So let's begin at D. This angle is 45. The angle that FAD makes with the vertical also is 45 degrees. Then since this is equilateral, that's 60 degrees. This is 60 degrees also, that's 60 degrees. So that's the force in AD, force in DE, and force in DF. So always assume tension. If the result is positive, tension. If the result is negative, compression. So first, RD vertical equals 0, vertical component of resultant at T0. And let's consider downward positive. So we have equals F dF sine of 60 degrees plus FAD cosine of 45 degrees because it is from the vertical. Then from here, we can express FDF in terms of FAD. So it is negative F cosine 45 over sine 60, negative 0.8165 FAD. Then RD horizontal equals 0. So we have FDE equals FDE plus FDF cosine 60, then minus FAD sine 45, the horizontal component of FAD. F8 minus FAD sine of 45 degrees. So substituting the value of FDF so that FDE is also in terms of FAD. So FDE plus FDF, which is negative 0.8165 FAD, cosine 60, then minus FAD sine 45. So from here, we can express FDE in terms of FAD because these are all FAD. So it is positive. FDE is equal to 1.115 of FAD. Then we proceed to joint E. So this is also FDE. We have FEF and FBE. This angle is 60 degrees. Take note that this angle is 45 degrees. The angle that BE makes with the vertical is also 15 degrees. 15 degrees. Because the angle that AB makes with the vertical is 30. So 30 plus 15 is 45. That's why this is 45 plus 15. So that makes it 60. So if the angle that BE makes with the vertical is 15, the angle it makes with the horizontal is 90 minus 15. So 75 degrees. So this is 75 degrees. And that is FBE. So first, RE vertical resultant, vertical component resultant that is 0. So we have FBE sine of 75, then minus FEF sine of 60. Then from there, FBE can be expressed in terms of FEF. It is sine 60 over sine 75 positive. FBE is 0.8966 of FEF. Then RE horizontal component of resultant at is 0 or summation forces horizontal 0. Considering leftward positive because all these are going to the left. So it is equal to FDE plus FBE cosine of 75, the component of this FBE here, plus FEF cosine of 60 because we consider leftward positive. Then substitute the value of FBE in terms of FEF and FDE in terms of FAD. So 1.115 FAD plus quantity 0.8966 FEF cosine 75 plus FEF cosine 60. So these two terms, last two terms are like terms. Then we can express FEF in terms of FAD. So it is negative because we transpose this to the left. So FEF is equal to negative 1.523 of FAD. Next is we proceed to joint F. So this is FEF also. This is FDF and this is FCF. So first, we have nothing to select except RF horizontal first 0. Horizontal component of resultant at F0. So let's begin with FCF. FCF cosine 15, positive to the right. The angle it makes horizontal is 15. That's why its horizontal component is FCF cosine 15 plus FEF cosine 60 because the angle it makes horizontal is 60. Then minus FDF also cosine 60. So FCF, FEF is negative 1 point, replace FEF by negative 1.523 FAD, then times cosine 60 minus FDF, which is negative 0.8165 of FAD from here, then times cosine of 60. So FCF can now be expressed in terms of FAD also. These two terms can be combined and divide by cosine 15. So using your calculator there, FCF is 0.3657 of FAD. Then FCF, then vertical, RF vertical equals 0. So let's begin with FEF, FDF sine of 60 plus FEF sine of 60. Then minus FCF sine of 15. Then minus Q. Take note there's a load here. So substitute the values of FDF in terms of FAD, FEF negative 1.523 FAD, then FCF 0.3657 of FAD. So FDF is quantity 0 equals negative 0.8165 FAD sine of 60 plus FEF, which is quantity negative 1.523 FAD, then sine 60, minus FCF, which is 0.3657 FAD, sine 15 degrees minus Q. So take note that we have FAD here, which can be combined. Then we cannot express FAD in terms of Q. So FAD therefore is negative 0.4715 of Q. So use your calculator, you may combine FAD first, Then transpose Q to the left. So it is Q over quantity negative 0.8165 sine 60 minus 1.523 sine 60 minus 0.3657 sine 15. So we'll get FAD equals negative 0.4715Q. Now that we have found FAD, we now proceed to joint A. So these are the forces involved at FAB, FAD, and FAC, which is the required. So red color. So we cannot solve FAC yet. We have to solve FAB first in terms of Q by setting RA vertical equals 0 or summation forces vertical equals 0 at joint A. So equals FAB sine of 60, the vertical component of FAB. FAB sine 60 degrees. The angle it makes with the horizontal is 60. Then plus FAD sine of 45. Then plus Q over 2. So substitute the value of FAD, which is negative 0.4715Q. Then we can now solve FAB in terms of Q. So negative 0.4715Q sine 45 plus 0.5Q. Q over 2 is 0.5Q. So FAB therefore is positive 0.4715Q sine 45 to the left minus 0.5Q divided by sine 60. So FAB is negative 0.1924 of Q. Finally, RA horizontal equals 0. So FAC plus FAB cosine of 60. Then plus FAD cosine 45. Substituting values of FAB and FAD in terms of Q. So 0 equals FAC plus quantity negative 0.1924 Q cosine 60 plus FAD quantity negative 0.4715 Q cosine 45. So FAC is positive because when you transpose this to the left, they become positive. So answer, FAC is equal to 0.4296 of Q. So this is the first solution. I'll present the second solution, but it is highly mathematical, not so mathematical. Just recall your analytic geometry here for the second method. So for the second solution, same problem. So remember that FAD was negative 0.4715 of Q from the first solution. We want to show that FAD is also negative 0.4715 of Q here, or very close to that. The sectioning would be this, circular. You can have circular section. There's no limit as long as you can solve the problem by method of sections. So the forces involved are FAD, FBE, and FCF. So that we can solve FAD, we must find the point of intersection between FCF and FBE so that there's only one unknown left. And we will call that point of intersection between CF and BE to be point G. So that if we set moment G0, these two unknowns are not involved, we can solve FAD. But we have to find G, coordinates of G, and from there, moment arms. Imagine that A is the origin. So let's call this YF, distance of F vertically from the x-axis, because this is the x-axis now. A is the origin. Then call this YD, and this distance, we can find this distance right away because this is 60 degrees. So tangent of 60 equals vertical distance over B over 2. Tangent 60 equals vertical over B over 2. Therefore, this is B over 2 tangent 60. B over 2 tangent 60 is equal to square root of 3b over 2. So I hope you know that. Or simply, because this is also b, equilateral triangle, b sine 60 is square root of 3 b, square root of 3 over 2b. So therefore, the coordinates of this point are b over 2, point b, b over 2, comma, square root of 3b over 2. While c is simply b comma 0. C, we need that later. This is the equation of the line point slope form. Y minus y1 equals slope x minus x1. Then the slope is simply the tangent of the angle it makes with the positive x-axis in counterclockwise direction to make it positive. Or if it is in clockwise direction, then make the angle negative. Tangent of the angle it makes with the horizontal. Clockwise negative, counterclockwise positive. Remember from trigonometry. So this is 75 degrees. The angle that BE makes with the positive x-axis is 180 minus 75 is 105. But if you make it clockwise, because BE is in this direction also, it is negative 75 degrees. So the slope of BE is either tangent of 105, press your calculator, it is negative, or tangent of negative 75. So I use negative 75 because it is clear here. Or tangent of 105, where 105 is 180 from the positive x-axis to BE minus 75, so 105. Tangent 105 or tangent of negative 75. So cosine of 15 degrees is B over 2 over distance CF. And distance CF is also distance AD. It is also distance BE because of, you look at the figure, it's the same. These are all 15 degrees. So therefore, distance CF is equal to zero point 0.5 over cosine 15, which is also distance AD. It is 0.5176 of B. So that YD is equal to distance AD sine of 45, because this is 45 degrees. So sine of 45 degrees equals opposite YD over distance AD, and distance AD is 0.5176. So YD is 0.366 OB. If YD is 0.366 OB, because this is 45, remember opposite and adjacent are equal. So XD, or the horizontal distance of D from A, which is the origin, is also 0.366 of B. So this is 0.366 OB, 0.366 OB, YD. That's the same. Then we need to find the equation of line BE first. Again, the slope of line BE is either tangent 105 or tangent negative 75. It's up to you. They are the same. Use your calculator. Then we select this point as y1, square root of 3b over 2, and x1 is b over 2, coordinates of b. So y minus square root of 3 over 2b equals tangent of negative 75, quantity x minus b over 2. So simplifying, y minus 0.866b equals tangent of negative 75 is negative 3.732x, or tangent of 105, that's the same. Then negative 3.732x times negative 0.5 OB is 1.866b. So simplifying, 3.732x plus y equals 2.732b. Call that equation 1. Then next line CF, so that we can find the equation of line CF. Then we can find the point of intersection between these two lines, BE and CF. The angle that CF makes with the negative x-axis is 15 degrees. So if the angle it makes with the positive x-axis is, because it is clockwise, negative 15. So the slope is either tangent of negative 15, or from the positive x-axis to that line, 180 minus 15 is 165 degrees. So it is either tangent of 165 or tangent of negative 15. Press tangent 165 and tangent negative 15, they are equal. So I'll use tangent of negative 15 degrees. Then C as coordinates B comma 0 for line CF, right? This is B comma 0 because A is the origin, and that is B, Y is 0. So Y minus 0 equals tangent of negative 15 or tangent of 165, quantity X minus B. So simplifying, Y equals negative 0.2679X plus 0.2679B. Simplify again, 0.2679X plus Y equals 0.2679B. So that we can eliminate Y, subtract equation 2 from equation 1. 3.732X minus 0.2679X is 3.4641X, then 2.732B minus 0.2679B is 2.461B. From there, we can now solve XB. XB is equal, XG rather, is equal to 0.7113B. So from A, this distance horizontally is 0.7113B. Then substitute into equation 1 to solve for YG. 3.732 times 0.7113B plus Y equals 2.732B. So YG is 2.732B minus 3.732 times 0.7113B. It should be positive but small value. YG is 0.07743 of B. So there's sense. Finally, moment at G is 0. So remember, that's 45 degrees from the horizontal. Moment G0, FAD has two components, horizontal to the left and vertical downward. Both horizontal and vertical components are counterclockwise about G. So let's consider counterclockwise positive. The horizontal component of FAD is FAD sine 45. So equals FAD sine 45. The moment arm is equal to YD, which is 0.366B. This vertical distance here is YD minus YG. And YG is 0.07743B. Now, for the vertical component, it is plus also FAD cosine of 45, and the moment arm is XG, which is XG 0.7113B minus 0.366B. So FAD cosine 45 degrees times quantity 0.7113B minus 0.366B. That's the moment arm of the vertical component of FAD from G. XG 0.7113B minus 0.366B. Then plus Q. Q, XG, moment arm is quantity 0.7113B minus 0.5B. Because this is 0.5 of B. Then that's it. Because we only consider forces crossed by this, inside this circular cutting section. So from here, we can now solve FAD. Don't mind the B because we can cancel it in terms of Q. So let's combine first for your easy calculation. So FAD sine 45 degrees times this value plus FAD cosine 45 times this value here is 0.4482 FAD-B. Then for Q, Q times 0.713 minus 0.5, 0.2113 QB. Cancel B. So FAD is negative 0.47144Q, which is close to this. So they are equal. Therefore, the solution should be the same as in the solution 1. We proceed to joint A, summation forces vertical 0, then the result would still be the same. So that's why FAC is also 0.4296 of Q tension. So that's it for this second solution to level 23 problem. So determine the forces in bars AC, FG, and BD of the plane truss supported and loaded as shown below. Angle DBA is 60, so this is 60 degrees, equal to angle CAB also. And angle CBA is 30. Angle DAB is also 30 degrees. So the horizontal component of reaction is 0 because there are no inclined load. Vertical AV, and this is R sub B. Then this angle is 30 degrees. The whole angle that CAB is 60, so this is also 30, 30 degrees, 30 degrees. Therefore, because ADB is a right triangle, 90 degrees at D, same is true with ACB, 90 degrees at C. Therefore, this is the hypotenuse, which is 6B, sine of 30, so that means this is 3B length. That's also 3B. Then the vertical distance is 3B sine of 60, so it is 2.5981B. While this horizontal distance is 3B cosine of 60, so 1.5B. Horizontal distance between D and B also is 1.5B. So we will call this theta 1 also by symmetry. This is theta 2, and this is also theta 2. So tangent of theta 1 is 2.5981B over this distance, which is 5B minus 1.5B, 3.5B. So tangent theta 1 is 2.5981B over 3.5B, cancel B. So theta 1 is 36.587 degrees. Again, theta 1 is arctan of 2.5981 over 3.5, where 3.5 is 5B minus 1.5B, which is the same as that. Then tangent theta 2 is 2.5981B over 4B minus 1.5. So 4B minus 1.5B is 2.5. So theta 2 is arctan of 2.5981 over 2.5. So theta 2 is 46.102 degrees. Then this is 3B because the total length is 6B minus 1.5B, then minus 1.5B, so 3B. Then that's also theta 2. Moment A0 to solve for RB. Counterclockwise positive. RB times 6B equals RB times 6B minus Q times B minus 2Q times 2B minus Q times 4B, then minus 2Q times 5B. Cancel out B, then we can solve RB. RB is equal to 19 over 6 of Q. Then we begin with joint G to solve for FCG, and we proceed to H to solve for FCH. Then knowing these two forces here, we isolate joint C as a free body diagram because we want FAC and FBC. Take note, FAC and FBC are perpendicular or 90 degrees at C. So these are the forces involved at joint G. This is required, so that's why it's red. That's FFG. So therefore, RG vertical equals 0. Our equation, or summation forces vertical equals 0 at G. So this is FCG sine of theta 2, sine of 46.102 degrees, then minus Q. So from here, we can solve FCG in terms of Q, 1.3878 of Q. Then at joint H, these are the forces. So RH vertical equals 0. So FCH sine of theta 1, FCH sine of 36.587 upward, then minus 2Q equals 0. So FCH is equal to 3.355Q. Then we draw the FBD of joint C. Remember that FAC and FBC are perpendicular to each other, and the angle that 3.355Q CH makes with the horizontal is 36.587. Theta 1, the angle that 1.3878Q, which is FCG, makes with horizontal is 46.102. But the angle they make with BC is, this one is 36.587 minus 30, so 6.587. The angle that 1.3878Q makes with BC is 46.102 degrees minus 30, so 16.102. So we set, let's call this U axis. RCU equals 0. FAC is in that direction, so equals FAC. The component of 3.355Q in that direction is plus 3.355Q sine of 6.587, where 6.587 is 36.587 minus 30. Then the component plus 1.3878Q sine of 16.102, where 16.102 is 46.102 degrees minus 30. So from there, we can now solve FAC, which is negative 0.7698Q. And that's the answer. FAC is 0.7698Q compression. Then we need FBC, so that if we solve FBC, we can now proceed to joint B. Then we can solve the force in FBD, which is also required. So R sub C, let's call this V axis, not vertical, but just V axis. So RCV equals 0. So take note that FBC has no component along U in the same manner that FAC has no component along V. So it is equal to FBC plus 3.355Q cosine of 6.587, this angle here, then plus 1.3878Q cosine of 16.102, the angle that this force makes with the V-axis is 16.102, and it is cosine. So FBC is negative 4.6666Q. Then we proceed to joint B. These are the forces. And take note that this is FBC, which is known. This is FBD, which is unknown. So the equation is simply RB vertical equals 0, or summation forces vertical equals 0 at B. So FBD sine of 60, the vertical component of FBD, plus the vertical component of FBC is quantity, plus FBC sine of 30, then plus RB. So substitute FBC, which is negative, so FBD sine 60 plus FBC, which is quantity, negative 4.666Q sine of 30, plus RB, which is 19 over 6 of Q. So from there, we can now solve FBD in terms of Q. FBD is equal to negative 0.9623Q. So FBD is 0.9623Q compression also. Then we consider FG is left. We consider section 1-1 and all forces to the right of that section. Because these three green forces meet at C, so it is best way to sum up moments about C, or M sub C equals 0. Considering clockwise positive, so FFG, moment arm 2.5981, OB, That's plus. Then plus Q, clockwise also. Q moment arm is 4B minus 1.5B, so 2.5B plus Q times 2.5B plus 2Q times 3.5B plus B. Then minus RB times 4.5B. Then there is one more left, FBD. So by principle of transmissibility of a force, take note, we sum up moment about C. Imagine that FBD is moved at D. Then there are two components of FBD, horizontal, which passes through C, so don't mind. Then the vertical, which is FBD sine of 60, then the moment arm is 3B. So minus FBD sine of 60, then moment arm is 3B. Take note that I move FBD to D by principle of transmissibility of a force so that it has only one component, the vertical component, moment about C. It's the same if you do not move, but this is the simpler one. By experience, we always did this in most problems in statics, unless this is your first time. So substitute 0 equals FFG times 2.5981. I cancel out B. Then combine these two Q's here without B. So 9.5Q, 2.5 plus 2 times 3.5, so 9.5Q. Then RB is negative minus RB is 19 over 6Q times 4.5. Then minus FBD, which is FBD is negative 0.9623Q, because it is compression, times moment arm 3 sine 60 after we cancel out B. So from there, we can now solve FFG in terms of Q. So FFG is 0.8660 of Q. Because it is positive, it is tension. So that's it for this problem. So determine the forces in bars A, B, C, D, and E, F of the plane truss loaded and supported as shown below. If A, B, C, D, E, F is one half of a regular octagon, solve in two ways. So the problem is very, very challenging, and we have to solve this in two ways. The more it becomes more challenging. So the first solution is the shortest one, and unless otherwise you experience this, then it's quick and easy, but you need to experience first. Take note that this is half of a regular octagon. Remember that the sides of regular octagon are equal, but because this is half, so for simplicity, let's just assume that this is 1 meter, or 0.5 of x if you denote this as x, x, x. So this is 0.5 of x. But x can be cancelled, so just make it this 1, 2 meters the other sides. Then this is 1 meter, so that we can easily compute for the angles. We can also express this as 0.5 x, 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 x. We can still solve for the angles because x can be cancelled. So this angle is 45 degrees. Remember, for a regular octagon, this is also 45 degrees. Then for the other members, this and this equal this member, and this member makes an angle of the same. So these two are equal. So this distance is 2 meters cosine of 45, so that's square root of 2 meters. Same is true here. And because this is 45 degrees, the vertical distance between D and E is also square root of 2. Same is true with B and C. So that this distance is equal to 2 plus square root of 2 plus square root of 2, 2 plus 2 square root of 2 meters. So we can now solve theta AE, which is equal to theta BF also. Tangent of theta AE is 1 over quantity 2 over 2 square root of 2. So theta AE, which is equal to theta BF, is 11.701 degrees. Again, this is arctan of 1 meter over 2 plus 2 square root of 2. You get that. Then tangent of theta AD is equal to theta CF. It is equal to arctan of 1 plus square root of 2 divided by 2 plus square root of 2. Again, arctan of 1 plus square root of 2, this angle here, which is equal to this angle. Arctan of quantity 1 plus square root of 2 divided by horizontal distance 2 plus square root of 2. You'll get 35.264 degrees. So for the reaction, summation forces horizontal. So A horizontal is Q also. Then the vertical, we do not know yet. Call that A vertical and RF. So let's solve for A vertical by setting moment F0, summation moment F0, clockwise positive. So we have AV times quantity 2 plus 2 square root of 2, then plus Q times 1, then minus Q times square root of 2. So AV can now be solved. AV is 0.08579 Q upward. Then RF is simply summation forces vertical. So it is equal to Q minus 0.08579 Q. I will not, you just subtract 0.08579 from 1, or Q minus 0.08579 Q. So RF equals 0.91421 Q. Then we consider this sectioning as shown in the figure. And we involve forces inside this section. So AV is involved, Q is involved, and FAB is involved, FCD is involved, FEF is also involved, all these unknowns here. And there are members that are cut twice, so it doesn't matter because they are cut twice. So this is FAB involved, FCD involved, and FEF involved, the red ones. Then I'll show you that these members that are cut twice, green arrows are opposite. So don't mind because they are cut twice. So we consider again forces, especially the red ones, and this AV and Q involved in the moment equation. So that we can solve FAB right away. There is intersection between CD and EF, which is here. I'll call that point G1. Same is true with CD and AB. They meet here. I call that G sub 2. So first, summation moment at G1 equals 0, clockwise positive. So we have FAB times 2 plus 2 square root of 2, the moment arm. Then that's clockwise. So plus Q times quantity 1 plus square root of 2 plus AV also. AV is 0.08579 Q. The moment arm is 2 plus 2 square root of 2. Then plus Q times quantity 1 plus square root of 2. So those are the involved forces. Then we cannot solve FAB in terms of Q. Minus Q times square root of 2. I forgot to include this. So solving for FAB is negative 0.2929 of Q, and that's the answer. FAB is 0.2929 Q compression. Then for FCD, just summation forces, R horizontal equals 0. So going to the left positive, so we have FCD, then plus Q equals 0. Those are the only horizontal forces inside this cutting section. And we can solve FCD. It is equal to negative Q, or FCD is Q compression. Anyway, there's a second solution, but it's very lengthy. Actually, there is a third solution, but only for civil engineering students can experience that. We call that method of substitute members. I have uploaded a similar problem which I solved in 3 ways, but the first 2 ways are here, similar to this. Then for FEF, you may sum up forces vertical or moment G2 equals 0. Then let's check later if it is in equilibrium, summing up forces vertical. So clockwise positive, we have FEF times quantity 2 plus 2 square root of 2, moment arm, plus Q times 2 plus square root of 2, then 0 passes through, then plus Q, this Q here, AV is not involved, plus Q times 1 plus square root of 2, and that's it. Then we can solve FEF, which is also negative 1.207 Q. So therefore, FEF is 1.207 Q compression. So that's it for the first solution, as short as that. The second way will be on the next slide. So this is the second solution, and it is lengthy, but you will arrive at the same results. Determine the forces in bars A, B, C, D, and EF of the plane truss loaded and supported as shown. So already computed. So just review the calculations. 45 degrees, 45 degrees. Then remember the distances. Then the angles. Theta AE equals theta BF 11.701. Theta CF equals theta AD 35.264 degrees. How to solve for 11.701? Arc for theta AE, arctan of 1 over quantity 2 plus 2 square root of 2. How to solve for theta AD? I already mentioned this. Arctan of 1 plus square root of 2 over 2 plus square root of 2. So 35.264. So first we proceed to joint C. Moment F0 to solve for AV. Just like before, AV times 2 plus 2 square root of 2. Then plus Q times 1. Then minus Q times square root of 2. So that's why AV is equal to 0.08579 of Q upward. RF is just Q minus 0.08579 Q. So RF is equal to 0.91421 Q. Same as before. So we start with joint C. These are the forces involved. This is required. That's why it's red. Then F, CF. So let's express all these forces in terms of FBC. Then after C, we proceed to D, D to E, then F. Then at F, we can solve for FBC in terms of Q definitely. Then when BC is in terms of Q along the way, then EF is also required. It will be in terms of Q. So RCV is 0, downward positive. So we have FCF sine of 35.264. This angle here, 35.264, the vertical component, downward positive, plus FBC sine of 45. So we can express FCF in terms of FBC. FCF is negative 1.2248 of FBC. Then RC horizontal equals 0. So FCD equals FCD plus FCF cosine of 35.264 minus FBC cosine of 45. So substitute the value of FCF. So F0 equals FCD plus negative 1.2248 FBC cosine of 35.264 degrees minus FBC cosine of 45. So FCD can be expressed in terms of FBC. It is positive 1.7072 of FBC. Then after joint C, we proceed to joint D. These are the forces involved. So first, RD vertical equals 0, downward positive. So F equals FDE sine of 45, downward positive, remember, plus FAD sine of 35.264, this angle, then plus Q. So express FAD in terms of FDE. So negative sine 45 over sine 35.264 is negative 1.7321, negative 1.2248 FDE. Then Q to the left, negative Q divided by quantity sine 45 plus sine 35.264 is negative 1.7321 of Q. Or negative Q over sine of 35.264, sorry. So negative 1.7321 of Q. Next, RD horizontal equals 0. So equals FDE cosine 45 minus FAD cosine FCD, then minus FAD cosine 35.264 degrees. So substitute the value of FCD, which is in terms of FBC, and FAD, which is equal to this. So 0 equals FDE cosine 45 minus 1.7072 FBC minus FAD, which is negative 1.7321 Q minus 1.2248 FDE, then cosine of 35.264. So combined FDE, cosine 45, then negative, negative, so plus 1.2248 FDE cosine 35.264 is 1.7072 FDE, then minus 1.7072 FBC, then 4Q negative of negative 1.7321, so positive 1.721 Q, cosine of 35.264 is 1.4143 Q. So finally, FDE in terms of FBC and Q is FDE equals FBC minus 0.8284 Q. Transpose this to the left, then divide by 1.7072, so that's why FBC. Then negative 1.4143 Q divided by 1.7072 is negative 0.8284 of Q. Then we proceed to joint E. These are the forces involved. So RE horizontal equals 0 first, or summation forces horizontal 0, leftward positive. So equals FAE cosine of 11.701 degrees, the angle it makes with horizontal, plus FDE cosine of 45. So replace FDE with this value here. So 0 equals FAE cosine 11.701 degrees plus quantity FBC minus 0.8284 Q, quantity cosine of 45 degrees. So we can now express FAE in terms of FBC and Q. FAE is, use your calculator there, 0.7221 FBC plus 0.5982 of Q from this equation here. Then RE vertical equals 0. So equals FDE sine of 45. Vertical component of FDE is FDE sine 45 minus FAE sine of 11.701, then minus FEF. Substitute the value of FDE, which is quantity 0 equals quantity FBC minus 0.8284Q sine of 45 minus FEE, which is quantity negative 0.7221 FBC plus 0.5982Q times sine 11.701 degrees minus FEF. Transpose FEF to the left, then we can express FEF in terms of FBC and in terms of Q. So 0 equals 0.85355 FBC, combine FBCs here, sine 45 and positive 0.7221 FBC sine 11.701 degrees is equal to 0.85355 FBC. Then for the Q, you just combine, that's the value, then FEF. FEF therefore is 0.85355 FBC minus 0.70708 of Q. Then we proceed to joint F. Forces involved are FEF, FCF, which is known already, then FBF, which is still an unknown. So RF horizontal equals 0, considering leftward positive. So we have FBF cosine of 11.701 degrees plus FCF cosine of 35.264, horizontal component of FCF. Then from there, we can express FBF in terms of FCF. And FCF is negative 1.2248 FBC. So 0 equals FBC cosine 11.701 degrees plus quantity negative 1.2248 FBC cosine of 35.264 degrees. So FBF can now be expressed in terms of FBC. It is equal to 1.0213 of FBC. Then RF vertical equals 0. So equals FEF plus RF plus FCF sine of 35.264 plus FBF sine of 11.701 degrees. So replace RF, FCF, FEF in terms of FBC. So 0 equals 0.85355 FBC minus 0.70708 Q. That's FEF plus RF, which is 0.91421 Q. Then plus FCF plus quantity negative 1.2248 FBC, then sine 35.264. Then plus FBF, which is plus 1.0213 FBC, sine of 11.701 degrees. So using your calculator, let's combine all the FBCs and all the Qs. 0 equals 0.35354 FBC. After we combine, then for Qs, 0.20713 Q. Use your calculator there. Finally, FBC is in terms of Q negative 0.58587 Q. Negative 0.20713 Q divided by 0.35354. That's the answer. That's FBC in terms of Q. So having found FBC, we can now solve for FEF, which is required. FEF is equal to this. FEF is 0.85355 of FBC, and FBC is negative 0.58587 Q. Then minus 0.70708 Q. So FEF is equal to negative, and it is compression, which is the same answer as before, first solution. Then we need FCD. FCD is 1.7072 of FBC, and FBC is negative 0.5857Q. So FCD is 1.7072 of negative 0.5857Q. So we can now solve FCD. It was negative Q, or Q compression. This also will give us Q, negative Q. So FCD is Q, which is the same as before, compression. Then finally, FAB. So it's still far. So we need this force FBF, so that when we transfer there, we can sum up forces vertical, we can solve for FAB. So FBF is 1.0213 of FBC. Let's put that here. FBF is 1.0213 of FBC, and FBC is negative 0.5857Q. So FBF is negative 0.59835 of Q. Then we draw the FBD of isolate B. These are the forces involved. Then red for FAB. So at B, RB vertical equals 0, because anyway these are in terms of Q already. So 0 equals FBC sine of 45, the vertical component of FBC, then minus FBF sine of 11.701 degrees, then minus FAB. Substitute FBC. So 0 equals quantity negative 0.5857 Q sine 45 minus FBF, which is quantity negative 0.59835 Q sine of 11.701 minus FAB. So it is FAB here. FAB to the left, so FAB is negative 0.5857 Q sine 45 plus 0.59835 Q sine of 11.701. So FAB is also negative. If you compute negative 58587 sine of 45 Q, then plus 0.59835 Q sine of 11.701, it's negative. So that's why FAB is 0.2929 Q compression, which is the same as the first solution. So that's it. It's very lengthy because the problems are challenging, and there are two problems here where we present, which I present two solutions.